So we have understood what is a generator and how does we use yield keyword inside a generator, because simple, a generator is also a function that returns a sequence of values, because when we use yield that becomes a generator, because yield will produce a sequence of values. Return, we will make sure that when we use a return, we will try to send a specific values to the function, whether it can be a single value, a group of values, right? That's what we have understood about the generators and the importance of yield keyword. Now we have seen the properties of functions, right? We have understood how does functions are considered as first class objects, and we have also seen the types of parameters or arguments. Now we'll be understanding the other types of functions, because till now we have seen user defined functions, right? That means I am defining a function such as like this. So we define a something and we write the dog string, or we can directly go ahead, I give return true or something, and we just give print of function call. That's it. When we execute this, what happens? True, you are going to print. These are all user defined functions. When I give some function name here, these are user defined functions. Now we'll understand the other types such as recursive functions, anonymous functions, along with built-in functions, right? If you see the word recursive, you have already known about that thing, because simple, what do you mean by recursive? It's something like a repetitive kind of thing, where when a function which is calling itself is nothing but recursive, right? You see the example of factorial and Fibonacci, that comes under the example of recursive function. So let me just start with that example, and we'll implement the factorial in two ways. How to write in a general normal function way, and how do you use the property of recursive. When I say recursive, a function calling itself, that's it. When I say recursive function, we can generally make it as function can call itself. That's the property of recursion. Function can call itself. That's where we see factorial, Fibonacci. These are some of the widely known examples. Even if you are aware of towers of Hanoi, that is one kind of it, right? So I'll be discussing about factorial here. Even you can use this, you can try to get the logic for Fibonacci, because programming is all about solving on our own and try to get the logic, because my mind thinks in a different way, your mind thinks in a different way. So just make sure that you try to get a logic, right? Because when you go for factorial, what is the logic you try to go for factorial? I'll just use my shell and I'll explain the logic of factorial, because most of you might know the factorial things, right? When I say it's 3 factorial, that is 3 into 2 into 1. Because when I say factorial of 3, let me write this as comment. When I say factorial of 3, how do we get this? That is, generally we multiply 3 into, we get factorial of 2. So 3 into, we just need to get factorial of 2. Then again, what is factorial of 2? Again, you go for factorial 2 into factorial of 1. Right? So factorial of 2 is, what do you write? So you get 2 into factorial of 1. Even when we go for modules, we'll see math module. Basically, it's obviously you just relate, it is very simple. You get factorial function from math module, you can directly relate it. But now, accordingly, we just need to go with the problem statement, right? So when you go for factorial of 1, that is 1 into basically factorial of 0. You don't have any 0 factorial value as 0, it is 1. So that is the reason when you go for factorial of 3, that is 3 into 2 into 1. So that's where you get the logic as understanding something like you are getting n into factorial of n minus 1. So when you go for factorial of n, if you can clearly understand the pattern over there, n into, you are trying to get factorial of n minus 1, right? Yes, so we'll be using that logic only. If you clearly see, when I write factorial of 3, what happened? 3 into factorial of 3 minus 1. If I ask factorial of 2, 2 into factorial of 2 minus 1, that is 1. So from this, let's try to use how does we use the property of recursive, right? So first let's write the program in a normal way. I'll just create a other way of factorial program, not as recursive way, because you can write in multiple way. I will be using a very unique approach in my own way. You can use your own way. So other way for factorial program is, first I define a function. So anyways, my function name is factorial, right? Whether I give input or I'll take input from user, it's up to you. Simple, my docstring is simple factorial representation. It's not the number of lines, it's about the logic you are trying to implement in the program. So think in that way, it will be easier. So what do I do? You know, right? So if it's factorial of n into factorial of n minus 1. So for this, first I'll take a variable as d is equal to 1, because 0 factorial is also 1. I'll take my initial value as 1. Initial value as 1. There you go. Again you write for I in range of starting with 1 comma. If I ask 5 factorial, that is 5 into 4 into 3 into 2 into 1. But if you take x range here, you go for 1 to 5, that is 1, 2, 3, 4 only. You don't get fifth value, because when you go for range, it is n minus 1. So give x plus 1. There you go. Here you write the logic. That's where you use assignment operator. D is equal to d into y. As I said, right, you won't believe it. That is the reason I told you those are not basics. They play a very vital role, because you are multiplying the previous value. 3 into 3 minus 1 into 2 minus 1, that is 3 into 2 into 1. There you go. And even if you want to return the value or print it, it's up to you. Just come out of the loop and give return d and just call the function. How do you call it? Print of factorial of. If you want to take input from a user, there you go, where I'll ask user to enter input directly x is equal to, so that any value we can take, x is equal to int of input of, enter a value. So whatever user may ask, our program will execute. Let me show you. So first let me give 3. What is 3 factorial? 3 into 2 into 1. Fine. Or else you can directly call the function here, because we are running the same thing. See, factorial of the docstring is 25. You see, very huge number. So factorial of 5, that is 5 into 4 into 3 into 2 into 1. 20, 60, 120. There you go. This is how you understood how do you represent the factorial logic by giving assignment operator, because just make it very simple, right? It seems interesting, right? Because the first value I have given 1, because we have used the same logic for Fibonacci series. If you remember, I have taken while loop and swapping the variables. Here just I am initializing first value and I am using my assignment operator. This is first way. Now what I will do is, according to recursive logic, I will just generate the factorial application, where I define my program name as again fact. Now I want to take my program name as fact, and again fact of x. Even I will take input from user, so I will just copy the same statement and I will paste it here, and I will write the docstring as recursive function representation, so that you will understand when you read the docstring or when you call the function. It's fine. Okay. How do you do it? First thing, you are missing colon here. Oh, sorry, it's your colon already present. So fine. So recursive function representation. You are thinking, okay, we have given for loop. What happens if you take while loop? Again, you need to give test condition. So clearly, I'll be using a very simple logic of understanding, or how do I use my condition, decision control instruction, where I give if x is equal to 0, because even 0 factorial is 1, right? That should return me 1. There you go. Because we can also use return for conditions. It's fine, because it is returning some value. Else, there you go. What it should return? It should return x into, same logic, n into fact of n minus 1. So x into fact of x minus 1. That is the reason I told you, very, very interesting logic, because this is the logic which we have derived. If you just clearly see what I told, factorial of n is n into factorial of n minus 1. That is the same logic we are taking. We are taking x into fact of x minus 1. That's it. It's done. Whatever you take, you can clearly see when you call the function print of fact of x. That's it. It's done. Very simple representation. Now let me close the previous shell and execute this. So when I execute this, it will ask for the user input. I'll give 5. There you go. Even when you call from here, see, the docstring is recursive function representation, fact of 3. And even if you go for fact of 0, it will give you 1. Fact of 10. Whatever you give, whatever you throw, it is clearly giving you the logic. Because we gave return x into fact of x minus 1. What happens here clearly? When you gave 5. So, if x equal to 5 equal to 0, no, right, it comes to else block. 5 into fact of 5 minus 1, that is 5 into fact of 4. Again it goes to function definition, where fact of 4 again comes to else block. 5 into fact of 4 in, what is fact of 4? 4 into fact of 3. So, 5 into 4 into 3 into 2 into 1. That is the reason I clearly gave you in the beginning itself. When you go for factorial of n, the logic is we'll be using the previous number, that is n into factorial of n minus 1. That's what it happened, and that's what clearly we have written in the function. Because for every time 5 into fact of 4, because 5 minus 1. So fact of 4, it comes again here, no if block, comes to else block. 4 into again fact of 3. So 5 into 4 into 3 into 2 into 1. So for every iteration, it goes the same way. That is the reason this is called as recursive. So function calling itself. That is the reason it is called as recursive function. And the very best example, even you can try for Fibonacci, because Fibonacci series is, it will add with the previous number. Here we are decreasing the value and we are multiplying it. So 5 into 5 minus 1 into 5 minus 2 into 5 minus 3 and so on. So that is how recursive function is very important. When you try to make sure you can call the function itself. That is, here you see function calling itself, because fact is the function name and you are giving here. Suppose what happens if I give any other name here, and clearly it will throw you a name error, obviously, because if you give enter a value, you see name error, because factor is not defined, because what is your function name? FACT. So make sure that you don't make such mistakes. And even what happens if you give some brace here? Why did I give brace over there? Everything, you start exploring it, then only you'll come to a conclusion, because I want you to make mistakes and learn from the mistakes. You see, no issues over there. Again, you got it very clearly. So fact of 3, you get it. But make sure where you are giving parenthesis here, because when you give parenthesis here, everything. So fact of 5 minus 1 and the same value. And even if you try to give it here, you see, close the braces properly and try to understand what is happening over there and make it simple, right? Anything you give, you get the same answer. That's where you try to understand how does the recursive functions play a very key role, right? The function calling itself, whether you give braces here or not, it's fine. But make sure you don't make any syntax mistakes and check the names. That's where people make mistakes, and once you get mistake, you get pissed off. Don't do that things, please. Make sure you go step by step, because we are learning scripting language. So execute step by step and learn from errors. Then you'll enjoy a lot. So please do follow that, because from my experience I'm telling you, just need to follow the same thing, follow the error, then you can make it very easy. That's what happens, function calling itself. So factorial, you just repeat it, function is calling again and again until the end where we are trying to get the result.